Okay. Now our new CLO is the statements of the new CLO is given here. And the CLO 1.3 of this course is saying what? Apply the supervised learning techniques. And so we will have to focus in this CO only on supervised learning techniques. And we will go with the logistic regression. We will go with the neural network. And then finally, we will go with the decision trees. Etc. is written here that we can continue with more, but still at least these three, we will go with that. And then 2.2 is saying that apply the techniques, whatever the techniques that you will learn here at 1.3, we have to apply those techniques on some given problem. So when this CO 1.3 will be finished, I will give you a practical quiz that will be again uploaded on the Blackboard. You have to submit it on the Blackboard. I will not take that quiz physically in the class, okay? Because the content is this statement of Dr. Imad Nabil is, I think it's true that the content is sufficient. We cannot finish this in this semester. And in this semester, we already have many vacations. Now, after the next week, we have again 1 week vacation or whatever. So I will use the option of Blackboard. So previously, we saw what is supervised learning. So I'm not going into that detail. What is the definition for that? You know that it is something labeled data. Huh? So we know that what is supervised learning. So it is something with the label data. So the data has the labels. Anyhow, leave it. So this supervised learning technique has two categories, classification and regression. And first we will start with the classification, and then we will move towards the second category, regression. Uh, all the algorithms that we are going to see first is logistic regression. Logistic regression is mainly for classification, but you can also use it for regression. Okay. Uh, so anyhow, this depends actually, but mainly it is for classification. Uh, Similarly, the second algorithm, neural network, that you will see that you can use neural network for classification, uh, but you can also use it for regression. In other words, I can say that I can use the neural network for supervised learning and also for unsupervised learning. So anyhow, we will first go with the classification and then we will move on to the regression. These things we already saw, so that's why I am just taking a reference of that and I'm moving towards the actual topic. So then what is classification? So we know that classification is something in which we have to predict the class or the category. Yeah, like you have seen many different data sets in our previous practice. Price of the mobile phone was what? That was a class, huh? So that was a prediction of that class. So if you are going to predict some class or category from some given data, you can use the simple word given data. Okay, maybe observed data, maybe it will get you confused. So that's why you can use the given data. So that would be called classification. So we have the training data, it is labeled. And in that training data that predict the class that we want to predict, that is also the part of training data. It is available there. And that class, we are calling it labels for that data. And then our model is again predicting that class which is available in that training data. But that training data, our model will get training on it. Our model will get learning from that training data. So that's why. After that, you can give any data outside the data set, okay? And then it will give you the answer. So anyhow, we already know what is classification. And there are different classification algorithms, logistic regression, support vector machines, decision trees, naive Bayes, random forest. And we will go with the logistic regression and decision trees, and neural network is not mentioned here, but we will also go with the neural network. The applications of this classification are can be in the area of speech recognition or handwritten recognition. Hmm? Biometric recognition means the fingerprints or whatever. And similarly, you can classify the documents. You can predict the category of documents. Huh? Anyhow, so these are the applications. This is the general information. Now we are moving towards the first technique, first supervised learning technique, and which is in the category of classification, which is in the mainly in the category of classification, logistic regression. We are not going to study the linear regression. Okay, that is easy. You have the x, you have the y. Okay, go on. So might be this is a difference, huh? So so we are going with the logistic regression. What is logistic regression? So like other models, in this model, we will have some input. This model will predict the probability of that input between 0 and 1. If it is probability, then you can understand it would be between 0 and 1. So like other model, like other probabilistic models, okay? I should have to correct myself. Like other probabilistic models, it will take some input, and then finally it will give you some probability value between 0 and 1. And how this model will give you the value between 0 and 1? By using some threshold, 0.5. And another question is how this model will give us those probability values finally? By using sigmoid function. This is the main difference. Okay, this is the main difference. This is the main difference. Okay, logistic regression will use sigmoid function to predict some class, or to predict binary class. Binary means either this class or not. Huh? This is binary. So if you want to predict some binary class, then you have to use sigmoid function. But you can use the logistic regression also for multi-classes, more than two classes, 3, 4, 5. Huh? Then you have to use another function that is available, that is called softmax. Other technique would be remain the same, but you will use this softmax function, which will give you multiple outputs. Okay. And this softmax is available in the neural networks. Okay. Because neural network can predict you multiple outputs and also one. If it is one, you can use the sigmoid. But sigmoid is mainly the function that we used in logistic regression. The identification of logistic regression is this sigmoid function and the linear regression. Linear regression is also in it. Okay. In the beginning, you will see the linear equation of the linear regression is also there. It is basically logistic regression will take the input, or you can say the output of the linear regression. Linear regression normally deals continuous values. Okay, you cannot use the linear regression for classification. Okay, you can use the linear regression to predict continuous values. House prices, huh? That we saw some example previously, house price. But anyhow, so now what is the now definition? We will use the sigmoid function. Then we will have it, this model will take some input. Then it will give you some probability value between 0 and 1. And how this model will calculate that probability? By using this sigmoid function. By using this sigmoid function. This sigmoid function has a curve, you will see. So this logistic regression is also an extension of the linear regression. Okay, we can use it for binary classification and also for multiple classification. Okay, moving on. What are the types of logistic regression? This is just a repetition, but these are the terms. The types of logistic regression is binomial, multinomial, ordinal, and there are also others, but I have mentioned only three. Discriminant analysis and many, maybe 6, 7 types, huh? But I have mentioned only three because these are the main. Other are the invariants of this, versions of this. Binomial means when you are going to predict binary classification. Okay. When you are going to predict binary classification, nominal normally for nouns you can categories. Okay. Bi means two. When you are going to predict only when you have two types of dependent variable. Dependent is normally the class that is predicted, and independent is something your input variable. Dependent is your output variable of the model. So here, when you are going to predict, when you are going to do the binary classification, then that is called binomial. For example, you want to predict 0 or 1, the class is 1 or the 0, or you want to predict pass or fail. So this is binary. Multinomial. So what is this type of logistic regression? Here you will predict 3 or more, and the word is unordered. 3 or more classes, but unordered. Unordered you can take different. You can use another word, different. When you want to predict 3 or more different classes, which does not have any order. For example, you want to predict cats, dogs, cows, whatever. Maybe humans because it is unordered. So that is what that is called multinomial logistic regression. And then ordinal. Ordinal is again 3 or more types of dependent variable. This is sophisticated word, okay? Dependent variable. But you can understand that dependent variable means predict class that will be predicted, huh? Your target variable, your target class, huh? So 3 or more, when you will again, ordinal is similar to this one, but only the difference is order. Only the difference is order. Multinomial is unordered and ordinal is what? Ordered. In linguistics, this ordinal is something different, but leave it. So, but what it means here, ordered. For example, if you have the survey scales, for example, it can be start satisfactory, very satisfactory, neutral, not satisfactory, not very high satisfactory or something like that. Sure, you can build a scale something like that. So if, for example, if you have something low, medium, high, so this is called ordered, okay, which have the link relationship with each other. So if you are going to, so then you can also use the logistic regression here, but then this type would be called ordinal. Moving next. Now, this slide is giving you a general idea about a probabilistic model, because soon we are going to start logistic regression. But before starting, we are learning some terms, huh? We are learning some terms so that we will not have difficulty there. So logistic regression is a probabilistic model. Then normally in machine learning, what are the main parts of any probabilistic model? Okay. What are the components? There would be 4 components. The first one would be feature representation. Input. Huh? Input. Generally, you can call it feature representation input. You have the data set, and in the data set, you have the features, the columns, huh? Which you are calling them features. So you will have multiple columns there, and we are representing it with xi. And if you will have 10 columns, for example, x0, x1, x2, up to 9, huh? Then you can represent it with x1, x2, xn. And then you will convert, or whatever, you will convert all those columns into the form of vectors, So then in probabilistic models, you will have vector of features. You will have a vector of features. Vector is, what is vector? Vector is a kind of array. I told you already. Vector is a kind of array. And then here you can understand that this is an array which has something for the first column, second column, third column, and so on from the data set. So this is the first component. Number 2, logistic function. What is logistic function? This logistic function of any probabilistic model, okay? Before starting, we are saying for any probabilistic machine learning model. What is logistic function? That function will compute the probability for the target class. Okay. What is logistic function? That logistic function can be the part of logistic regression, can be the part of neural network, can be the part of decision tree, anything. Okay. And every model has its different logistic function. Can be different, can be same, because it is something, the equation of the probability that you are going to use in that model. So what is logistic regression? This will compute the probability of the target class. So here you are seeing it will compute what? Y cap. We are saying that target class, we are representing it with Y cap. Okay. This cap is like that, okay, but it is like that in the textbook. It is like that. Sorry. But here I'm just writing it in the PPT, so that's why it is at a little bit side. Huh? So we are representing it with Y cap. And what is this Y cap? This is the target class, the class that your model is going to estimate, for which, or in other words, the class for which your model is going to calculate the probability. And normally, what is the equation for the probability? This is the equation. Probability of that class given X. This is X, okay? This X is given, input is given, and you are going to predict some class Y for that. So this is the normal equation for finding the probability, for finding normal general equation. You can write this equation for everything. And then inner detail will be changed, okay? Inner detail will be changed with addition of some other concept. So logistic regression is what? It is a equation which will compute the probability for the target class. So that equation would be called a logistic function. And we can here we can use sigmoid, equation for sigmoid, and equation of the softmax, etc. We can use this thing. I'm just giving examples here, okay? You have to compute probability and then probability through sigmoid or probability through softmax, okay? Number 3, third part, third component of the problem, objective function. Objective function. Objective, what is the objective of your model? Learning, okay? Training, okay? Learning, the good word is learning, huh? Otherwise, it is something related to training of the model. When your model will learn, what it will learn? Probabilistic models always learn some weights. Okay, I'm using the word weights. Probabilistic model, when you have the vectors, then the probabilistic models will always learn some weights. Why those models will learn those weights? To minimize the error of the data set, of the training data. Okay. To minimize the error in the training data. We can expect that whatever the data set we will have, the errors would be there, huh? Error in the values. So our models cannot perform good until we will calculate the error through some equation. It is again an equation, okay? Objective function, it is again an equation. So our model cannot perform good until they achieve the objective. And what is that objective? Minimizing the error in the data set, or you can say training set. How we can minimize? This is that name is written there. We can, okay, you can call. So this objective function, you can call it, shortly you can call it loss function. Loss is again, when you have the errors, then you will have a loss in your accuracy, yeah? So you have to calculate that loss. Another name for error minimization, okay? another name. So error minimization, one name. I can also say, some other person can also say it is loss, huh? Loss that we will experience in the data set. And now we are calling it loss function. And so basically objective function, if somebody will say objective function or loss function, okay, both are same. Some other person can also say cross entropy loss function. That is the same thing, but it is one step ahead than the loss function, okay? It is one step ahead because in cross entropy loss function, okay, it's a, you can say loss function, you can discuss equation without weights, but cross entropy loss function, then you have to present that same equation with the weights. But this is another debate, so leave it. So cross entropy loss function, this is for the neural network, for the logistic regression. Okay, because neural network is using the logistic regression. So that's why cross entropy loss function is something, and is some equation. These names have some equations, okay? Is some mathematical equation. That equation is for the neural network or for the logistic regression. And that equation will be the objective function of the generally objective function. But if I will say cross entropy loss function, then this would be the objective of logistic regression or neural network. So this is the third thing that we have to find for any model. If we are going to understand any model, we have to see what are the feature vectors, what are the feature vectors. We have to see how that model is computing probability to predict the target class. We have to see what is the loss function for that model. And then finally, the fourth thing, we have to see what algorithm that model is using to optimize this objective function. Okay, you have some equation to find the error. You have some equation to find the error in the data set, but it is not one time step. It is iteration. So then you need some algorithm that when the training will be finished, then you will have your uh, value for the last function updated, optimized. So for that, you need some algorithm. And that is the fourth part of any probabilistic model. So you have to use some algorithm to optimize the objective function. And what is the example? Stochastic gradient descent algorithm. Again, for logistic regression. You can also use it for the neural network. Stochastic gradient descent algorithm. So this is example, but these headings are the parts. Huh? This is the name for the component of any probabilistic model. If you are going to study any probabilistic model, you have to find these four parts in it. Only then you can understand. If I say only logistic regression, okay, logistic regression, maybe we are studying that logistic regression here, maybe here in step number 2. But this is not only the logistic regression. Complete logistic regression is starting from here, and then all these four parts, huh? Then the model will be in running state. Okay. What are the phases of logistic regression? If we will use the logistic regression, what would be the phases? Yeah, that would be the 2 phases, training and testing. And what we will do in the training? We will train the system, but we will do what? We will have these weights, W and B. You will understand what is meaning by W and what is the meaning of B. If you have already studied this machine learning course, then I'm sure that you know that what is this. But we will go again through these things. So in the training, we will train the system. But in this training phase, what will happen? Our weights will have the optimized values, okay? Normally in probabilistic models, initially we give some initial weights, And then with each iteration, these weights are getting updated values again and again on each iteration. But anyhow, so in the training phase, what we will do, we will use the stochastic gradient descent algorithm, and we will use the objective function, which is cross entropy loss function. We will we will use both of these steps to get the updated values, to get the optimal values for the weights, and bias would be fixed. Okay, don't think too much about bias. Okay, this is the value that you will give. You will give 0.5, 1. You will check on which the model is giving you more accurate result. But these weights, okay, these weights, your model has to learn, and for that, this training phase is. Otherwise, the second thing with this weight is input, but leave it. I don't want to make the things complicated. If I am talking about weights, then only weights. And what is the test? That is simple. We will give some test data, and that data can be X. Okay, we are representing it with X. We will give some sentence maybe, or something we will give as a input. This is not now the training is complete, and now you are testing your model. Okay, and then you will give some example X. Your model will do what? It will calculate the probability of class that the model want to predict given the input data. X is now you have given the input data, and when it will calculate that probability, then it will return that probability value, and based on that probability value, you can say that your class which you want to predict, it can be predicted, which means one means predicted perfectly, or it cannot be predicted. So this 0 means if the value is 0, okay, not predicted. And this is predicted. You can see. Anyhow, this is general theory. Moving next. Now we are going to see that what is the concept. So now we are going properly with the logistic regression. Okay. So that's why I use the word concept. Now we are going to start logistic regression properly. This logistic regression will do what? First, the first thing is logistic regression will do what? It will do classification, because it is a classification model. But what it will do, what it will take, what would be the form of its input values and what would be the form of its output values? We already talked about it. This is a model of classification. It will do classification, but it will take what? It will take real value. Okay, real value. You can understand fractional values of independent variables. Independent variable means input, your data set, and dependent variable means output, the class that you want to predict. So this logistic regression will do what? If it is a function, that it will map the real values of independent variables from your data set into a value between 0 and 1, which means probability. It will give you finally the probability of the target class. Either it is 1, either it is 0. This is one sentence. Or in easy words, you can say it will do what? It will transform the continuous value, which means real value. Which will transform the continuous value, which means the real value of continuous value output. So this is some output of linear regression. Linear regression normally gives us continuous values, real values, okay? That's why we normally use linear regression for predicting price of the houses. We have seen the example, just in the beginning. So that's why we said that it is an extension of linear regression, because whatever the output of the linear regression is, output of linear regression is real values, not 0 and 1, okay? Not 0 and 1. The output of the logistic regression finally would be what? 0 or 1. Okay? For binary classification, output would be what? 0 or 1. And the output of linear regression would be what? Real values, continuous values. Okay, so what we are going to say? So logistic regression will what? It will transform the continuous value output of the linear regression. So it will use the linear regression, and whatever the output of that linear regression is, it will then transform those values, means real values, into what? Into categorical value output. Categorical means classification. Category 1 or 0, 1 or 0. It will give you those values by using the sigmoid function. Sigmoid function is a function which will finally convert your real value into probability value, 0 or 1, okay? So this is just a definition. What is logistic regression? If I will say what is logistic regression, and if you will say to me it will do the classification, this is incomplete definition, okay? So now, so in logistic regression, what would be the input? Now we are going to start with the input. What would be the input? Input would be the features, and features in vector form. So input would be independent input features, and we are now going to represent, for example, if we will represent it with x, then it will have something like that. x11, you already have seen here the vector of features from x1 to xn. And here it is something x11, x12, x13, and so on. Similarly, x21, x22. So this is representing all values, okay, of all columns. This is your input data, okay, which you can convert into the form of a vector, or, okay, we are seeing it features also. And if this would be the input, and then what would be the output? Output would be y. We are now slowly, we are giving labels. We are using variables, because next we want to convert this information from theoretical understanding to mathematical equations, okay? We will convert. So that's why we are using now symbols. So now y. Y is what? The class that our model wants to predict. And then that class can be 0 or can be 1. Okay. If it is a binary classification, then okay, class 1, class 2, nothing else. Or you can say it means yes, it means no. Huh? Now, moving next. So, if some input will be given to the model, how our model will decide? How our model will decide? If we will give some instance, one example, and if we are calling that example x, which is input, how this model will decide on it? Now we will go slowly by building some mathematical equations, because we want to understand what logistic regression is. We know that it will do classification, but how? Now we are going into details. So learning weights. So how the logistic regression will learn weights? Keep this concept aside, okay? Because learning is not something in the beginning, okay? So that's why that is during the training phase. So keep this thing aside. We will discuss this learning later on. But suppose you will have some input and you are calling that you have some xi. Xi means x1, x2, x3, your features, huh? Your features. This model will do what? It will take that input and then it will, I said, take the weights aside. How these weights will be calculated? Take this concept aside. We will discuss it later on. But assume that you have the weights in the model available, because you will provide the initial values to the weights and then later on in the training it will be updated. But assume that weights are available. Huh? So when you will, when you were testing your model, at that time training was finished. Okay. So it means weights are updated and optimized there. And if you will give some input, which you are calling it x, then that input, first your model will multiply your input xi with the weights. And if we are calling weights with another notation wi, wi is for w1, w2, w3, w4. x1 will have the weight w1, x2 will have the weight w2. Just mathematical relation. x3 will have the x3 will have the weight w3, x4 will have the weight w4, and so on. So it means that the input and the weights would be similar format. Similar format. So this model will do what? This model will multiply this input with the weight first, and then it will sum up the result of the multiplications of each multiplication, and then it will sum up the weighted features. Weighted features mean when you multiply the x1 with the w1, when you will multiply the x1 with the w1, it is a weighted feature now. After multiplication, it is whatever you have, that result is called weighted feature. So first we will multiply, then we will sum up the result, and then finally we will add bias term into it. And bias term is fixed, okay? That b is fixed. You will give maybe the value 0.5, maybe 1, maybe 0.25. It's up to you. And now, if this whole theoretical sentences, if I want to write them in a mathematical equation, now, then this would be the form. If I want to write this whole story in a mathematical form, then this would be the form. Here, what it is, here, this is the weight, and this xi is the input. So if input is x1 and the weight is w1, then we are multiplying, and then we have a sigma over it, which is going from I1 to n, and we can put the values here. First, it would be w1, x1, okay, multiply. Due to this sigma, it would be plus, and then w2, x2, okay, multiply and then add, and then plus, and then I would be 3, and in this way, w3, x3, that is easy. So we will multiply and then we will sum them up. And then finally we will add the bias into it. So this whole theoretical understanding, we are writing it into the form of a mathematical equation. Into the form of a mathematical equation for the beginning, for starting. So now if something is like this, then in mathematics we have this equation, sigma I is equal to 1 to n ai bi. If you have something this is what? This is a dot product notation. This is what? Dot product notation. We want to convert it into dot product because here we are using vectors in the input. Vectors of features. So I can say this notation. I can say I want to rewrite this notation in other form. Which form? This form. I want to replace this part of this equation with w dot x. And how I can use that? Here I am giving reference to some mathematical equation that we can represent this thing in mathematics with this AB. And here we have AI and BI going on with the sigma. So we can represent this whole thing, the multiplication and the summation, with A dot B. This is called dot product, okay? This is called dot product. So here we are representing it now with w dot x. And now this equation has the new form now. Z is equal to w dot x plus b. Up to this point, agreed? Up to this point, agreed? This is just starting, okay? So here, so this weight is what? We already know that these weights would be the real values. These weights, x can also be the real values, okay? But these weights will also be the real values. It can be negative, it can be positive. So that's why it is mentioned here. It can be negative infinity, positive. Moving next. Now, so we have this equation up to now. Z is equal to w dot x plus b. If you will see the equation of the linear regression, that would be similar to this. Okay. Okay. If you will see, I'm just giving you the reference. Okay. It will have the similar shape like that. But we have not reached on the, so this is something we have up to now. This is not logistic regression. Here it is the logistic regression. Here we will use the sigmoid function on the input Z. So this is now our a kind of input. Actually, our input to this model is X, and weight is already available there. We are multiplying and then adding bias into it. We are calling it Z. But now this Z will become the input to the sigmoid function. Now this Z will become the input to the logistic function, step number 2. Step number 1 will become the input of step number 2. Okay. So now we will use the sigmoid function. What is sigmoid function? Maybe you have seen this curve already. This sine curve is called sigmoid. This is called sigmoid, sigmoid curve, or you can say. And here, these values that you can see on x-axis, these are the values that you can call it. It is the values of Z. And these values that you are seeing here on vertical direction, this is the value of the probability starting from 0 to 1. Okay. So from 0 to 1. From 0 to 1. And here the values are going maybe in positive infinity and then negative infinity. Positive infinity and then negative infinity. So this Z can be positive in positive infinity or negative infinity. Okay. And then that Z will be converted into this probability through this curve. And this sine curve is called sigmoid function. It is like sine curve, so that's why I said sine curve. Otherwise, it is not that one. So that is sigmoid curve. And this curve, how we will calculate the sigmoid? And if you will see in the mathematics, okay, you can calculate the sigmoid by applying, this is a sigmoid symbol. You can apply this, and here we are passing Z into it. Z is our previous equation. Z is our previous equation. And then when you will pass this Z into it, and when you will apply sigmoid over it, sigmoid will give us probability value. This is what we study. But how? We don't know. We will see now. Okay. But here in previous slides, we studied that sigmoid will provide us what? Sigmoid will provide us what? Probability value. Somehow here or somehow here, it will give us the categorical value through sigmoid function. So here and here, when we will pass Z into it, sigmoid will give us the probability value. And then that probability value would be the value of this class, Y. Y is what? The class that we want to predict. Here, I am not mentioning it with Y cap because I am copying this equation from the textbook and the cap was not there, okay? If I will edit it, I will write that cap, but anyhow, leave it. So this Y is what? This is the class that you want, your model want to predict through this sigmoid function. And if you will see the equation for the sigmoid, you will see this equation in mathematics there. You can see on the internet. Okay. The equation would be something like that. If I will show you, let's have a look. Okay, equation of maybe sigmoid. Okay. Have a look over here, 1 over 1 plus e raised power minus x. And here we are saying x. And here, what we have here? 1 plus 1 plus e raised power minus z. Z is our variable here, our input variable. So this is the equation. So this is the equation to calculate the sigmoid. And this sigmoid will give you what? Probability value between 0 and 1. between 0 and 1. Let's see it further. How we will calculate? We now know the equation, but now this equation will calculate these probability value. How we will calculate this probability? This is the detail for that. What we want from our model, we want to predict that the class would be either 1, which means predicted perfectly, or we want the probability of the class y, either it is 1, or we want the probability of the class y, either it is 0. 1 means the class is predicted perfectly, 0 means not. And we want the and this model will give us, if it is a binary classification, it will give us the probability value for one class. And how we can calculate the, for example, if this model will give us probability value for y is equal to 1, it can give us maybe 0.7. Then how we can confirm that this is 0.7, this is the probability value? If the total probability is total probability is 1, and if we will do 1 minus this value, we will get maybe 0.3, huh? And then what? This value and that value, when you will sum them up, if it is 1, then it is sure that this is the probability value, huh? This is the confirmation. How you can confirm that you get not any real value, but you obtained the probability value through this method. So now here we are going to confirm that how the values, real values that we will get after this step, from this step, the values that we will get, how those values would be probability values. We want to confirm this. This is how we can check it. If we are going to see the probability of the class when the class is predicted as 1, then the equation is what? Sigmoid of input. Input is z. Here, input is z. And the z is equal to what? W dot x plus b. So which we are, so that z we replaced it with this w dot x plus b. Nothing else, okay? Nothing else. And then by using that previous equation, which is 1 over 1 plus e raised power minus z, so it is like 1 plus 1 over e minus z is what? W dot x plus b. So we are just now 1 over 1 plus s e minus w dot x plus b. We are just using the notation of, we are expanding or opening the z into w dot x plus b, nothing else, by using that equation. Clear? So mathematically, this will give us the probability value where if we are going to predict our class as 1. If this class would be predicted, then this would be the probability mathematically. And if this class would be predicted, then how we can find the probability? We already find this probability. We have to subtract this probability value from 1, nothing else, huh? From 1. So 1 minus sigmoid of w dot x plus 1. Okay. The opened form of this is already here. Just write that. Take the LCM. Take the LCM. If you will solve like that, this is the LCM now. This is the LCM now here. It will multiply with this 1. And this 1 will be cancelled with this 1. Positive, negative. And finally, you will have what? E minus w dot x plus b as a numerator of this fraction, or on the above side of this. So e minus w dot x plus b. So this would be the probability value mathematically for this class. Okay. We are not finding actual values. We are just giving the equation for that. Okay. We are just giving the equation for that. Now the question is, okay, we have these probabilities, but the question is now how we will decide, how we can decide. We have the probability values. It can be 0.7 something or 0.6 something or 0.2 something, 0.1 thing. We are discussing logistic regression stepwise, okay? We started with the input and now we are discussing what? Second step, objective. Uh, 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 what is the logistic function, okay? We are discussing this. We started with this feature representation. We started with this feature representation, and now we are on the second step, logistic function. Okay. How we can, now the question is how we can decide on these values, on these probability values, because decision is either 1 or 0. There is no 0.7 or 0.6 or 0.2 or 0.1. Huh? Decision is what? The output of this model would be 1 or 0. There would be no 0.7 or 0.4 or 0.2 or 0.1. Huh? So how we can decide finally? So again, we are saying that if we will give some input x to this model, then this model will give us the probability with this mathematically. Y is equal to 1 given x. Okay, we are just writing it mathematically. It will give us some probability value. It can be 0.7, it can be 0.5, 0.4 something. Then what we will do? We will make a threshold. We will introduce a threshold of 0.5. If the probability value that we will get, if it would be 0.5 or higher, we will make it 1. And if it would be lower, we will make it 0. Okay? We will make it 0. And then here we are writing it y cap, because this is the final answer almost by the model. And here we are writing it with y cap. Y cap means estimated class, predicted class. Okay? And it will this, so this, the value of this y cap would be 1 if the probability value on any input you will get greater than 0.5. Then we will make it 1 and 0 otherwise. Okay, this we can do in the coding, just one line. Huh? In the coding, we will introduce threshold, and by using this threshold, you can shift whatever the probability that you will get here. You will convert that probability value into 1 or 0. 1 or 0. Because 1 is 0 means decision. Okay, now we are taking an example of sentiment classification now. So here in this example, we will have a text about movie, the review text, huh? And we want to predict the class, either that review given by some audience, huh? Given by some audience, either that review was positive or negative. We want to predict, huh? We want to predict through this logistic regression, through this logistic regression. And here, for this example, we will do what? We will introduce these. First, we will talk about input. So we will introduce these 6 features in this example. We will use these 6 features: x1, x2, x3, x4, x5. What are these features? X1 would be what? It would be the count of positive. We will see in the movie review text, that would be a paragraph. Okay, so the customer feedback, you can say. But here we have movie. So, okay, when you will have a account there, you are a customer of. Huh? You are a customer of, what is that popular website? Indian website? Netflix? Netflix, yeah. So anyhow, so now, so if you have seen the movie on the Netflix, and then normally people are also giving their feedback there. So that is, feedback is called review text. Okay. So now what our first feature is, we will see in this review text, we are calling it document. We will see that, do we have a positive lexicon? Positive lexicon means positive words. Good. For example, good is a high. The movie was extraordinary. Huh? So these extraordinary is something positive. So we will see what are the positive words in the document, and we will count them. Huh? We will count them. So this is our first feature, count of positive words. And x2, the another feature would be count of negative words, negative lexicon. Lexicon means dictionary. Okay. Lexicon means, by the way, dictionary, huh? And lexical item means word. Okay. But anyhow, leave it. We will also count the negative words in that review text, which we are calling it doc. And then X3 is what? We will see that if the word no is available in that review text or document, then we will make the value of this variable or feature 1. If there we will not find this word no in it, then we will make the value of this 0. Okay. And then we have another feature x4, and what it is, we will count the first and second pronouns. We is the first pronoun, huh? Second pronoun is what? In English, I and we are the first pronoun. Second pronoun is what? You, huh? And third is what? He, she, it. Don't give me that feel that I am just speaking and speaking and you are not listening, okay? Because you are playing with your beard. Sorry for that. So X4. So X4 is a feature that we will count the first and second pronoun in the document. And X5 is what? It would be a feature or a variable. In that variable, what values we will take from the document? From document means this review text. We will see that if we will find this exclamation symbol in the text, we will make the value of this variable 1. If we will not, then we will make the variable 0. Okay. And then finally X6. We will count all the words in that text word. All the words. We will count one by one. Huh? And we will count all, and then we will take log of that, whatever the value. And here, these are the values taken from that text, but you will see how. So here, from that, in that text, 66 words are available, which you are taking log of that. And then you are getting 4.19 values. But what is that? On the next slide, let's have a look over here. This is the text now given to you. This is the review text. And then you saw, where is your X1? Okay, then you found this, that, and that. These are positive words, huh? And you counted them, and it was 3. So this is your first variable feature, huh? X1. Clear? According to the previous information. Now, X2 was what? X2 was count of negative words. So now, this is a negative word, hockey, and this is a second rate. This hockey is a negative word, second rate. Movie was a second rate, huh? So that is a negative word, and you counted it, and now the X2 will have the value 2. This is your second variable, huh? According to that information. X3 is what? You have to look for this word no. And when you read this text, then you found only one. Where is X3? Then you found only one no word in it, and that's why this is your X3, and it is only one count. When you found it, here we are not counting. Here we are seeing only that if no is there, we are making the variable X3 1. Similarly here, X4. First and second pronouns, count them. Here we will count. So I, me is a form of I, okay? You, second form, and this is first. So count them, and it is what? X4 is equal to 3. And similarly, X5. X5 is what? Exclamation symbol. We don't have any exclamation symbol here, so that's why it is 0. And finally, the count of all words in that document. So count is what? When you counted all these words in this paragraph, it is 66. And now 66, you have taken the log of that, because you have to take the log, and then the value you got is 4.19. Okay, so that is mentioned here. That is mentioned here. So now this X1, X2, X3, X3 with the values is, we want to use the logistic regression that you have seen previously. So your Xi is what? X1, X2, X3, X4, this thing, huh? But you don't have the vectors. So because we don't have a model with the training, so that we can say what are the vectors, what are the weights. So that's why we will assume some weights in this example, that this is the weight given to us. So if this is the question, then in this question weights are given to us already, okay? Because we cannot train any model, right? So it is given to us that, okay, these are the weights. This is W1, this is W2, this is W3, this is W4, W5, W6, according to the features X1, X2, X3. Huh? So these are the, you have to assume that we have the vector already, okay? Because we don't have a physical model here which we can train and we can see the what are the values for the vectors, optimal values. So that's why it is given to us. And the bias that we are going to use is 0.1, okay? 0.1, not 0.5, not 1, 0.1. Now you have the xi, now you have the wi's, and you have the bias, and you have the equation. What you will do? So initially, what you will do here? What you will do? So in this sentiment classification example, we have seen our equation was what? For probability calculation, this was our equation, huh? For this and that, through which we can calculate the probability. We have the weights, we have the input, we have the bias, huh? So now we will do what? We want to predict the probability of this positive class given input. We want to predict the P for probability. We want to predict the probability of the negative class given input. So then what? Here we are writing mathematically. Probability of positive class given X would be what? It would be probability of, it means that the Y, if Y is the class according to, then it would be 1 given X. It is not necessary to write this thing. You can just write this and then you can go on to that right hand side directly, okay? But it is just giving, relating with the previous information. And then here sigmoid of this equation has what is the equation for this? When y is equal to 1 given x in our logistic regression, this is the equation. Sorry for this drawing, huh? So this is the equation, and that equation is that one. Simply, so we are going to use this equation here. Simply sigmoid w dot x, and here w means wi, x mean xi here, because this equation is only for one vector and one input, huh? But here we have multiple features, so that's why xi and multiple weights. So here first we have to write, if we replace this w with the vector, then this is what you are writing, that whole vector here, this vector, okay? This is w, huh? Or you can call it, this is wi, w1, w2, w3, something like that, huh? So we are writing that vector here, and then x. And what is the value of x? You got this value from here, x1, x2, x3. So write them into the form of a list, huh? Write the values of all these x's into the form of a list, and then this will become like that, 3, 2, 1, and finally 4.19 after taking log, huh? And then adding the value of the bias, because here we are taking the value of bias 0.1. Okay, this is the dot product. How we can do the dot product in mathematics? Multiply this first with the first, second with the second, third with the third, fourth with the fourth, and similarly and so on, huh? So you will multiply. So what you will do, from the previous equation, we already know. From that previous equation, we know how we can do the product. So multiplication and then sum the result. Each multiplication, you have to sum them up. So here, you have to multiply this with this 3, multiply. You have to multiply this 5 with 2. Similarly, minus 1.2 with 3. You have to multiply all, and then you have to sum up all these 6 values, huh? And you have to add the bias into it, and then you will get what? 0.833. You will get this value. And when you will take the sigmoid of this, it will give you the value 0.70. Just to check on Google. You can, I don't have the calculator, so I don't have sigmoid. This is something I done for you, huh? I already tested. And here it is giving you some from the book. It is something like that, but I don't want to. Okay, that is 0.70, but Let's see something different. I want to check that the value is 0.33. Huh? Give me the value for this. Okay. What is, okay. It should have to give me the value. Sigmoid of 0.833. Normally Google provide us the result, but now it is not giving up. Okay, this is the sigmoid calculator. Relu. Where is the sigmoid? This is the sigmoid, I think. And here, if we will give value 833, it will give us 0.7, huh? 0.69, which is after rounding something, 7 something. This is bookish data, so that's why it is rounded there. 0.70, huh? And then probability for the negative class. Okay, when this class is not the class, then okay, for negative class is what? When this class y is 0. How we can find this? We have already found this, so we only have to subtract this probability from 1. So 1 and minus this thing, and for this thing we have found the value this 0.7. So 1 minus 0.7, we have the 0.3. So these are now the probability values. These are the probabilities values. This is for sentiment classification up to now. But these are the probability values. But now if you have something 0.5 is your, if 0.5 is your threshold, then based on that threshold, you can say that it is 1 and it is what? 0. And then this class is predicted, huh? You can say at the end. At the end. Because this is what we talked here. How we can decide? I said we can introduce threshold of 0.5, and then finally we can say if it is greater than 0.5, okay, 1. If not, 0. It is up to you. You can make it 0.4. It is up to you. So this is example for this logistic regression with this sentiment classification. You have seen it theoretically. And one other thing is, if your data set is large, so then logistic regression will work better than naive based classification. Okay. But now mostly people are using mostly neural network. Everything is something about that. I want to continue, but now you will say only 4 minutes are left, huh? But you came late, okay? But this will take at least 30-40 minutes, this loss function. Yeah. This logistic regression is still, the understanding is still not complete yet. We have seen the execution, but we have not seen the third objective, which is objective function to minimize the error. And the last objective, some algorithm. Yeah. We have not seen this thing. Okay, we have seen some examples of this. Yeah. So that how logistic regression will do in training phase. In the training phase, it will calculate the weights, cross entropy loss through that algorithm. So in training, it will execute those 2 steps, the final 2 steps. And it is starting from here. First, here it is loss function, and then it is loss function has how many slide loss function has? So from here 1, 2, 3, 4. So I must have to stop it first. Sorry.